standard normal distribution. So first of all, so now we're ready to get into the actual normal distribution. We've been talking kind of around the the fringes about it. We've kind of talked about this is what everybody, where we want to get, right? The normal distribution is where we want to get. We kind of talked a little bit about it. So far, what do we know about the normal distribution? We know that it's shaped like this. It's a bell shape. We know that, right? What else do we know? We know the percentages, right? That was the 68, 95.5, 99.7 rule, right? 90,
I thought it was
95. 68, 95, 99.7. Anyway, okay, so here we go. So we know this, right? One standard deviation, front and back of the mean is 68%. We go out 2 standard deviations from here, low and high, it's 95% and 99.7%. Okay? So we know that. Okay, that's good. What else do we know? We know that it's symmetrical, right? It's exactly symmetrical, right? A normal distribution is exactly symmetrical. Okay, all right. So that's really about all we know, right? So we have a mean and we're going to have a standard deviation, right? So the thing about the normal distribution that really kind of separates itself from other distributions is that once you know these two parameters, you know everything you need to know about this guy. Okay? So once you know these two, everything else comes into place. Okay, so this is a normal distribution. Now look, we're supposed to be learning about a standard normal distribution, not a regular normal distribution. We're talking about a standard normal distribution, okay? So before we get there, okay, so let's go back to, what does it say? So we're on page 228. There is an orange definition there. So let's read that. If a continuous random variable has a distribution with a graph that is symmetric and bell-shaped, that is symmetric and bell-shaped, okay, as in figure 6-1, it can be described by an equation using in the formula in 6.1, we say that it's a normal distribution. If you look at that formula, it is pretty complicated, okay? And no, you do not have to know this, okay? Just know that there is an equation that governs normal distribution, okay? I'm never going to ask you to reproduce this, okay? So don't worry about it. And then we're going to move on to something called a uniform distribution first. Okay, what is it? What would you guess when it says it's a uniform distribution? What does uniform mean? Besides what you're wearing. What? Huh? In order, but what else? Evenly distributed, right? Uniform means they're the same, right? Isn't that really what it really means, right? Uniformity, right? Uniform, right? Uniform means they're the same, which means that no matter where I am in the distribution, it has the same value. So in a uniform distribution, it's always going to look like this because no matter where you are, it's always going to be the same. Okay, this is why it's called a normal distribution. Okay? I mean, a uniform distribution, I'm sorry. Okay, so if you go to page 229, definition. A continuous random variable that has a uniform distribution has a uniform distribution if its values are spread evenly over the range of possibilities. So evenly over the range of possibilities. So if I'm I'm the Dallas Cowboys, and I have a uniform distribution of scoring a touchdown, which means that the possibility of me scoring a touchdown at the first quarter or the first start, the 1 minute, 2 minute mark, or the 5 minute mark, or whatever to at the end of the fourth quarter, it's the same. Okay? So I have 4 quarters, correct? Or how many minutes do I have? Each quarter is how many minutes? Well,
15.
So we have 60 minutes, correct? Right? Which means that the probability of me scoring a touchdown at time 5 has to be what? In other words, what is this value here? It's a probability distribution, so the height here times this has to be what? When I add up all of the probabilities, what does the probability have to be? Probability always has to be 1. Remember that, right? It always has to be 1. So since this is 60 minutes, 1 over 60, correct? Because 60 times 1 over 60 is 1. So the probability of me scoring here is that. What is the probability of me scoring in the first 5 minutes? What? It would. I had to, what? 5. So it's 1 over 60 times 5, isn't it? Really? Correct? Okay. All right. So that's how a uniform distribution works. Uniform meaning they're all the same. Okay? Go to example number 1. Read example number 1 for us. Isaac. Okay, so let's go ahead and flip there. Thanks. Flip the page. If you go there, it is 0 to 5 here, correct? We're talking about 0 to 5 now. 0 to 5 minutes. Okay. So, what's this going to be now? 1 over 5, correct? In other words, because 5 times 5 has to be, 5 times 1 over 5 is 1, right? Okay, so here we go. So it's 0.2, really. 1 over 5 is 0.2. And the question they're asking in example number 2 says, given the uniform distribution about that, find the probability that a randomly selected passenger has a waiting time of at least 2 minutes. So this would be the 2-minute mark, at least 2 minutes. So it's going to be on which side? That side or this side?
Right side.
This side, right? At least 2, right? At least the 2. So the probability was 1 over 5, and if 5 minus 2 is what? That's the probability. Pretty high level math here, right? 1/5 times 3 is 3/5. Woohoo. Okay, all right, so let's go back to the normal distribution now. This is the uniform distribution. So we're going to go to back to the normal distribution. We're going to try to define what a standard normal distribution is. Okay? A standard normal distribution is nothing more than a normal distribution that has a mean or average of 0 with a standard distribution of 1. This is what we call the standard normal distribution, when you have a mean of 0 and the standard deviation of 1. Well, so let's go. We're on page 231. There's an orange definition there. Read that. See if that makes sense to you. We just talked about it. Okay. And so, what is my point here? Let's say this is, I don't know, negative 1.2. Okay? So it's negative 1.0, negative 1.2. What is my z-score here? Remember z-scores? Do you remember what the z-score was?
X minus median over.
Correct. It's the point. It is the point, right? Minus the mean, which is 0, divided by standard deviation. Well, guess what? It's the same thing. Your z-score is the point. The point is the z-score itself. This is why the standard deviation, the standard normal distribution is important. Okay? Because now this allows you to go back to the back of your book and go to table A-2. So if you go back on page, what is this? Page 684. Page 684. Let's go back. This is a little bit of memory lane. You've been here before. Okay, so there's a negative z-scores and a positive z-scores, 684 and 685. Okay? So if I asked you in this situation, what is the probability of me being here? How would you find that out using that graph, using that table? Where am I at? Negative 1.2. So I'm on page 684. I'm on the far left column, reading off negative 1.2, correct? And that reads off as what, Isaac? What did you read? 0.1151, right? So that 0.1151 is what was here. The probability of being here is 0.1151. If I asked you what is the probability of being on this side of negative 1.2, what would your answer be? What? 1 minus. It's 1 minus the 0.1151, correct? Because when I add everything up, it has to be 1. And since this here is 0.1151, the rest over here has to be 1 minus that. Does that make sense? Are we good there? Are we good there? Can anybody tell me another way to find this out without using the table?
Do the math.
What? Calculator. Remember the calculator? We did this in the calculator? Bring your calculator out. Bring your calculator up. You're really to go vacation. Okay, what are we looking for? We're looking for the command that says norm CDF.
I forgot what that's at.
Second var stats, right? Second var stats. So you're going to put in 4 different parameters. You're going to put in the lower bound. So the lower bound is all the way over here, right? We'll just put negative 100, a nice even number, right? Negative 100 is going to be way over here, right? And then my upper level is negative 1.2.
Wait, why is it negative? It's just
You can put negative 2,000 if you want. You can put negative 2001 if you want. Any big, large, negative number works. Okay, then you have negative 1.2, and then my mean, which is 0, and then my standard deviation, which is
1.
all right. Plug and chug. What do we get?
1.15.
There you go. Right? You should get 0.1151. Did we get that? Did everybody get that?
No.
Naila? Not Naila, I'm sorry. Did you get it?
Yeah, mine says error too. Eliana says error.
Error?
You guys are tripping. I got it.
Did you get it? Sam? Sam, help favor. Isaac? You're doing it right now.
Yeah, there's says error.
Negative 100.
It says syntax.
Oh, it says syntax error. You're not using the correct zeros, or not using. What'd you get? You get error?
I got it. I don't know why.
I figured it out.
Okay, so I
I don't know why.
Second bars?
Did you put like,
I'm about to cook.
put like space?
Oh, was that with the wrong
They
name?
just
I
look
thought
like
about 100.
But I just
I
deleted
don't
them
know
and
how you play
redid it.
spaces.
Okay, I don't know.
I just deleted them.
Eliana, are we good?
They used the wrong.
No?
They used the wrong negative.
Oh, using the wrong
They
negative.
used the minus sign.
I did not use the minus.
At least that's what I did. They did the
Isaac.
Oh, wait, why?
Nyla?
My 100 was the minus sign. I did.
You have to
You
use,
good?
like,
Are we good now?
negative
We're
sign,
good?
not the minus.
Okay, so we're just waiting for Eliana.
Yeah, but my 100 had this. It was already
Okay, you need to know how to use this. We're gonna do this all through second semester.
second vars.
How many points are you supposed to? Like,
4.
Yeah, is it 4? 4 decimals?
Oh,
Does it really matter?
doesn't really matter that much.
They used 4 actually.
Where did the lower number come from?
The lower number, I'm just starting from here, right? I didn't take over here, right?
Yeah?
So I'm just putting something that's really negative here. So negative 100, negative 50, negative 40, all these things work.
Okay.
Okay?
Okay, that makes
Okay,
sense.
okay. All right, so we know how to use this. We know how to use the table also, right? So you guys need to know both methods. Is what I'm saying. We're good? Okay, good. So we are going to, where are we at? We're good with it. We're good with that. We are good with that. So we're going to do two methods, right? The first one was using the graph. The table. The second one was using the norm CDF. Okay? So I want you to use the two methods, and I want you to tell me the area between negative 1.71 and 2.0. I want to know that area, okay? And I want you guys to work in groups. I want this to be one group. What group number 2, group number 3, group number 4. Both methods. It'll be easier if you do the norm CDF first because you know what you're supposed to get. Okay?